All right, guys, today we're going to be using Pythagorean theorem to help us with yet another task. And again, you're going to figure out by the time this is all said and done that Pythagorean theorem, again, I'm a big fan, and it's because you can use it for so many different things. But here we're going to see how you can use Pythagorean theorem to determine whether a triangle is in fact a right triangle, which we already know. But you can also use it to help you to figure out whether triangles are acute or obtuse. So let me just do a little bit of review as we get ready to get into this. Let's think about acute and obtuse. When we're talking about acute or obtuse angles, remember we said that an acute angle, and I'm just going to draw one real quick, like that, is always less than 90 degrees, right? And then we said that if we're talking about an obtuse angle obviously is greater than 90 degrees, okay? So those definitions in and of themselves will help us quite a bit here when we start talking about this. This says if you've determined that a triangle is not a right triangle, then you can determine whether it's an acute or obtuse by using one of the following theorems. So this first page gives you these theorems, and here's what I really want you to pay attention to, okay? And you will notice that this looks extremely close to what we seen when we worked on that first packet. And you'll remember that I said, well, most of the time we write it as a squared plus b squared equals c squared, like that, right? That's the way we remember it from grade school. And so when we looked at that first packet, they kind of had it flipped on its head. They had it written as c squared equals a squared plus b squared. And I think I even said maybe in that video that we're going to eventually come back to that. And so here we are today, okay? So you notice what it says here. It's given us this scenario, which looks a whole lot like this, okay? But you'll notice it has the greater than symbol. And notice what our theorem says. It says if the square of the length of the longest side is greater than the sum of the squares of the lengths of the other two shorter sides, then the triangle is obtuse. So you notice again, obtuse, we said, is always greater than 90. So I want you to think about the fact that obtuse is greater than 90. We kind of we associate this symbol with being obtuse because it's greater than, and we associate this symbol with acute. And so that works here with this same scenario. It's saying if c squared is greater than a squared plus b squared, then this is going to be obtuse, okay? Conversely, it also tells us that if c squared is less than a squared plus b squared, then we can know confidently that that triangle is in fact acute, okay? Probably the easiest way to dive into this is just dive into some problems. It's got a couple of examples down here that'll kind of try to help you understand what they're saying. But let's just dive into a couple, two or three of these, and then I think it will really help you to understand what you need to do. And so let's look at number 19 on this side. It says the lengths of three sides of a triangle are given. Classify each triangle as acute, right, or obtuse. And so the first thing you're going to do is you're going to try to set this up, and you're going to set it up in reverse of maybe the way we've been doing it. Instead of doing a squared plus b squared equals c squared, you're going to set it up the other way. But what you're going to do is you're actually going to leave out the equal sign or the greater than or less than sign. You're going to figure out what really needs to go there. So here's what I mean by that. So let's look at number 19 real quick. And I may have to go to another sheet of paper as well, but that's fine. We could try to figure this out. So number 19, it says 30 and 40 and 50, right? Well, which one, if this is a right triangle, and we don't know the answer to that yet, but if it was a right triangle, which one of those three would be the hypotenuse? Just think about that for just a second. And we said there's some very specific information about the hypotenuse. The hypotenuse is always across from the right angle, but it is also the largest side, right? And so if these are my three numbers in my triangle, then this number right here, 50, would have to be the hypotenuse if this is truly a right triangle, okay? So let's think about this for just a second. So let's set it up, c squared, and again, I'm going to leave this blank because I don't know what it is yet, and I'm going to do a squared plus b squared. And this will kind of make sense as you go. And you notice on the other side, they made a little like a T-chart looking piece, and we could do that as well. So here's what we've got so far. So C squared, we know that this would have to be C because it's the largest side, right? So 50 squared. And then let's just fill in these other two. Again, they doesn't really matter whether it's A or whether it's B. So we'll just say 30 squared plus 40 squared. So now we've got some math to do, right? So we're going to look at this and we would say 50 squared. 50 times 50, what does that give me? Well, it's a big number. It's 2,500. Okay. And then 30 squared is 30 times 30, which would be 900. And then 40 squared would be 40 times 40, which is 1,600. Now let's do the only math that we've got left. We have to ask ourselves, we've got 2,500 on this side. We've got 2,500 on this side. Those two numbers are equal. So what kind of triangle is this? If C squared equals A squared plus B squared, then what does that tell us? That tells us that this triangle is, in fact, a right triangle. So for number 19, that would be right. So let's do number 20, and we'll work through the same kind of scenario, and you'll kind of get an idea of what we're looking at. So for number 20, again, we're going to set it up the same way, C squared, A squared plus B squared, and we'll go ahead and do this table. That seems like a good idea to keep everything organized. And so which one would be my C out of these three numbers, 10, 11, and 13? If this is truly a right triangle, then this one would have to be C, right? Because it's the longest side. So let's go ahead and fill that in, 13 squared. And we'll go ahead and substitute in these two values as well for A and B, and let's see what happens. So we have 10 squared plus 11 squared. So first things first, we need to do 13 squared. So 13 squared would be 169. Okay. 10 squared is the same thing as 10 times 10, which is 100. And 11 squared is 121, correct? So you can see already that perfect squares list is really coming in handy. So let's do some more math and let's see what's going on here. So we've got 169 over here. Over here I've got 100 plus 121. 100 plus 121 would be 221. Well, these are definitely not equal, right? So what are we saying here? We're saying that if it's not equal, then is 169 less than or greater than 221? Well, 169 is definitely less than 221, which tells me what? Remember, go back to our theorem just a few minutes ago. If we take C squared and it is less than A squared plus B squared, then we know that that triangle has to be an acute triangle, okay? So that means number 20 would be acute. And you do that same process for every single one of these, okay? So 21 through 25, you're going to do that same process. Obviously, down here, you've got kind of a challenge question. It takes a little bit of time and thought to think about. And this applies to number 26 and 27 right here. And then you've got this figure here that you're going to use for actually three different problems here, 28 through 30. So the things to remember are this, and this is going to be very important actually for the work you're going to be doing tomorrow. You will need this as well, okay? So if C squared is equal to A squared plus B squared, then we know already that is a right triangle, okay? If we do this math like we did up here a few minutes ago, and C squared is less than A squared plus B squared, then we know it's an acute triangle. And if C squared is greater than A squared plus B squared, then we know it is an obtuse triangle, okay? So that's really the key that you need to have. I would even put that on my notes somewhere and make sure I had it, because again, you're going to see that again. If you have any questions or concerns, make sure to reach out to us, and we'd be glad to help you. Honestly, we do not care one bit to help, and we would love if more people would get in touch with us and say, hey, I need some help, or get on a Google Meet or whatever we need to do in order to try to really help you guys be as successful as you possibly can be. Thanks.